We have a shaft with a step-down diameter and it is subjected to bending. We know that the ultimate tensile strength of the material is 950 MPa. In part A, we will determine the stress concentration factor and then estimate the fatigue notch factor. From figure 8.12, for diameter 2 over diameter 1, which is 1.2 in our case, and the notch radius over diameter 1, which is 0.0375 in our case, the stress concentration factor becomes 1.96. We have the information that the notch radius is equal to the fatigue notch factor minus 1 over the stress concentration factor minus 1. We will find the notch sensitivity from Peterson model, which states that the notch sensitivity is equal to 1 over 1 plus alpha over the notch radius. To calculate alpha, we will use the equation 10.7, and according to this equation, alpha is a function of the ultimate tensile strength. You can find this function in problem 10.5. Also, it is in your books. And when we compute alpha for 950 MPa, we will obtain 0.10163 millimeters. Since we know alpha, we can now say that and when we make some arrangements, we will see that the fatigue notch factor minus 1 over 1.96 minus 1 will be equal to 1 over 1 plus 0.1016 over 1.5, which is notch radius. So we will obtain the fatigue notch factor as 1.899. We can now move to part B. We will now find the bending moment amplitude MA, which can be applied to the notch shaft for 10 to the power of 6 cycles, and the safety factor will be 2 in stress. According to figure 9.24, we know that the sigma is equal to the half of ultimate tensile strength. And we also know that it is equal to the fatigue notch factor times SA. Again, when we look at figure 8.12, part B, we will see that SA will be equal to MA over pi times D1 cube times 32. So we can say that SA is equal to 0.5 times sigma u over kf, and it is equal to 32 MA over pi D1 cube. And when we leave the bending moment alone, we will see that it will be equal to 0.5 times sigma u times pi D1 cube over 32 times the fatigue notch factor. Now we can substitute the values. And MA will be equal to 1571.6 Newton meters. But don't forget to consider the safety factor, which is 2. The safety factor on stress is equal to MA over MA bar. So that MA bar will be MA, which is 1571.6, and over the safety factor, which is 2. So MA will be equal to 785.8 Newton meters. So we can say that for a safety factor of 2 in stress, a bending moment of 785.8 can be applied to the notch shaft for 10 to the power of 6 cycles.